Today we're finishing up Unit 4, and that means you're going to be covering, I'm going to go over limiting reactants again. That'll be your most complex, at least for Unit 4, the date. And I want to do also something called empirical formulas, which is something that is being de-emphasized lately. But anyway, it's something you're going to get into in your next chemistry class for sure. So I want to go over it, give you an idea what that's all about. Okay. Now, tests for practice tests I have not made yet because basically it's just going to be stoichiometry problems. So there really isn't a practice test. The problems we're doing late yesterday and today are what's going to be on the test. Very similar. It's very, very focused. And the reason why it's really focused is so that the emphasis in your next chemistry class is very crucial you understand this. And Unit 5 as well. Unit 5 is on solutions, which involves a lot of molar calculations, etc. So it flows very nicely into the next unit. All right, so let's look at some problems here. Here, if you go to Files, Unit 4, Stoichiometry, there are a lot of practices worksheets here for you. Lots. On limiting reagents and reactants. We haven't talked about yield yet either. Your wet lab today, by the way, 4 people showed up lab yesterday. And they were explaining that the email I sent out was confusing. So I didn't mean it to be confusing, but anyway, theoretically, I had you down for wet lab, stoichiometry wet lab, and the dry lab. Most people interpreted that as either or. So what I decided to do yesterday was, if you'd like to do the wet lab for extra credit, that's fine. You have to make sure you're dressed properly and you've done the pre-lab. That's the only way I can resolve it in a fair way. So, okay. So if you want to do that lab, if you need to make up a lab, for example, it might be good to do that lab and just substitute that lab in for the one that you missed, for example. You could do that. But anyway, that's the situation on the labs. The wet lab is a very good lab. It's on stoichiometry. It's pretty straightforward. It's a good lab. Too bad I got it a mixed message to you. Okay, and one of the things covered in the wet lab is percent yield. So I'm going to go over percent yield also today. But you can see there are a lot of worksheets here. I also printed off the dry lab because it's pretty, the answers are on there, but there are quite a few of them. So it's pretty long packet, but they're in the lab right now. So if you'd like to pick up one of those, instead of printing it off yourself, that's fine. Okay. The dry lab is not optional though. What's optional is the wet lab, okay? Everyone needs to do the dry lab. That'll be wonderful practice for Monday. Okay, so are there any questions about the lab? Okay. Okay, so let's look at a typical reaction. Let's see, what do we want to do now? Let's do let's burn ethane. Okay. So C2H8, it's ethane. It's a common chemical used in um, in two parts. Okay. Anyway, ethane is burned a lot. So it's similar to methane. It's found a lot in natural gas. Okay, so let's come up with a question here then. Okay, 23 grams of ethane are burned and 34 grams of oxygen are consumed. How many grams of water are produced? Okay, so right away you go, oh, and one other thing. Okay, so we have two new terms that we haven't really talked about, and that is these three terms: theoretical yield, actual yield, and percent yield. Now, a good friend of mine is a general manager of a Union Carbide chemical plant. They produce pesticides. His deal is getting the highest percent yield out of the reactions to maximize profit. That means the actual yield needs to be high, close as possible to the theoretical yield. Now, the theoretical yield is if everything goes perfectly, which you know how life is, doesn't go perfectly. If everything goes perfectly, the actual yield and the theoretical yield will be the same, but they're never that way. It's always actual is less for lots of reasons. There's purification processes, there's just inefficient parameters in the reaction, just a number of reasons why that reaction isn't going to go perfectly. So this is actual yield. That's part of the given, but it's not limiting the reaction. The ethane or the oxygen is the given, and one of those is going to limit the reaction. Okay. Percent yield is so that percent yield is actual over theoretical times 100. Okay, so the first thing we need to do is figure out how much water is produced theoretically. Excuse me. But because there are two givens, we have to figure out which one is limiting the production of water. So that means there are two calculations we need to do. Let's do ethane first. Now, again, this is going to fall into the three-step process. First step, convert given to moles. So we need to figure out the molar mass of C2H8. Okay. Okay, that gets us to moles of ethane. Next, let's see. Let me do one thing here. Now we need to transition from ethane over to water. And that would be from the balanced equation. So water's 8, ethane is 2. And then we need to go ahead and go over to grams. Okay, the molar mass for water is 18.02. Okay, for just looking at the ethane, ignoring the oxygen, we're looking at 52.1 grams of water. All right, let's look at the oxygen now. Eight, coefficient is 8 for oxygen. Okay, oxygen produced less water, so that's the limiting reactant. Now that means the limiting reactant is totally used up. None is left. The other is in excess. And the question is, how much in excess? That's another calculation. So we're going to take our oxygen, our 34 and based on that, we want to see how much of the ethane is being used. Now this will tell us how much of the ethane is used. Okay, so we've used a little over eight grams, but we started with 23. So how much is left over? That's the last calculation. Okay, so we've got 14.6 grams left over of the ethane. Now, the next question is, what is the yield? What is the percent yield? Okay, so we are getting 19.5 grams theoretical. So this is the theoretical. If everything works perfectly, we're going to get 19.4 grams. However, the actual yield was 567. So it's going to be 567 over 19, what was it, 19.4. We're looking at what, 29. 29% yield. Now, 29% yield, I just made those numbers up. 29% yield, just FYI, is a very poor yield. And it's interesting on circumstances. For example, the method to make meth was developed by Germans in World War II. Hitler fed his men meth so they can have more energy, so they could do the blitzkrieg marches, etc. However, the method used was horrendously inefficient because it was made in the field and they just wanted to get it done. So normally when your yield is really low like that, you have a lot of impurities. So the next job is to get rid of the impurities and purify your sample. In the field, they didn't do any of that. And a lot of explosions. It was a very risky process, but the yield was very, very low, extremely poor quality. And when you consume drugs of poor quality, you have no idea what the side effects are going to be. None. And they were probably different each time. It was in the winter they made it, or was it in the summer? How clean was the water? It goes on and on and on. So anyway, so a yield of 29% is very poor. And then the reasons are many. Now, if you do the wet lab, you're going to be looking at a percent yield. And this is exactly what you're going to be doing. You're doing a theoretical first calculation, and then you can actually weigh what you got. And from that, you can calculate the percent yield. Okay. So are there any questions on this? Now, this is as evolved as you're going to get doing stoichiometry. When you go into 1A, 2A, or 3A, they're going to be doing stoichiometry problems, and they're going to be zooming along because they've assumed that you've either had an AP chemistry class in high school, or you've taken a prep class like Chem A. If you haven't taken any of those, the class is going to be going very fast. And the worst place to take 1A is in the summer. I mean, it goes blindingly fast. It's crazy. One of my students who took Chem A with me here, very good student, a solid 100% student. He didn't miss 1 point the whole time, at least on tests. His labs were, as far as the tests go, though. And he took me Chem 1A over the summer at Sac City. And he didn't do so well. He just said, "This is crazy." I said, "You were one of my best students in Chem A." He says, "Because you went slower." That's the nature of the beast. My recommendation is take no science over the summer. Take humanities or whatever, but don't take a science class because it's just the amount of information is incredibly large and the speed it just moves. Okay, so there are no questions about yield, percent yield, and limiting reactants. Okay. Want me to do another one? Or everyone's saying yes? Okay. Let's do some gaseous stuff instead of grams. Now, when you're doing these problems, figure a whole page per problem. You have plenty of room, and don't try to jam it all into something small. Okay, 23.2 liters of ethane at STP, of course, are burned and 34.5 grams of oxygen are consumed. How many molecules of water are produced? The actual yield of the water is 5.67 times 10 to the 24 molecules of water. Okay, two givens. Ethane and oxygen are both given. That means we have to do a limiting reactant process. So let's have the all right, so let's start with the ethane. Next, we need to convert that over to water. And then we need to convert that to grams, or not grams, but number of molecules. Okay. Is everyone okay with the conversions I did? All right, let's do the oxygen next. Okay, so the oxygen is the limiting reactant. That means it's totally consumed 100%. That means we have excess ethane. So now we have to calculate how much excess we have. So we're going to start with our limiting reactant, the oxygen. Now, this is a situation where do we figure out how much liters of excess ethane, then we have to convert it to grams to find out how many excess we have there. Because we can't subtract yeah. If I didn't ask it in the question, you don't need to calculate it. Normally I do though. Most of it depends on who made up the question. Also percent yield. Frequently they don't ask percent yield, but I always put the yield question in just to show you what the yield is about. But it's a good question because the question didn't say that, did it? Okay, so we're going to start with oxygen. And now we're going to go to now this will give us how many liters of the ethane was used. And then to figure actual yield, the actual yield is 5.67 times 10 to the 24th molecules. Actually, let's change it to, instead of 24, let's do 22. Otherwise, it doesn't make sense. Yes, exactly. And this is actual. But the actual has to be less than theoretical. That's why I have to change it to 22. I'm just making these up on as we go. That's why. Okay, so yield. Okay, actual is 649.23. Oh, excuse me, that's theoretical. And then actual was 567.22. Okay. Now, if you break this problem down into steps, it's not too bad. Yeah. That's theoretical. Well, first of all, the first two calculations determine which is limiting the reaction. And the second one down limits it because there's less of them. Okay. All right. So the limiting reactant is also theoretical. In other words, if everything goes perfectly, that's what we're going to get. The limiting reaction always determines how much yield you have. Now, some problems don't even ask you for specifics on product. It just says which is the limiting reactant. So you just choose one. Doesn't matter. I tend to be real specific, though. Real specific. Okay, so that's basically it for Unit 4. I've given you lots of practice. And you've got to do a number of these before you see the pattern, particularly simple stoichiometry with not a limiting reactant involved. Okay, so what I'm going to do is